From the moment of the Big Bang, the universe has been on a journey of evolution, a journey that spans billions of years and countless cosmic events. Out of the unimaginable heat and density, space itself expanded. Energy transformed into matter, creating the fundamental building blocks of everything we know. From this chaotic beginning, the universe cooled and particles began to form. These particles, the first atoms, were the seeds of future stars and galaxies. Gradually, gravity drew these particles together, forming clumps that would eventually become stars, planets, and galaxies. Over eons, vast clouds of hydrogen and helium coalesced, driven by the relentless pull of gravity. It is within these swirling clouds that the seeds of galaxies were sown, each cloud a potential birthplace for countless stars. These structures, bound by gravity, would become the building blocks of the universe as we know it, forming the intricate cosmic web. Imagine a time when the universe was young, less than 1 billion years old, a time of rapid change and formation. This was a period of intense activity, where the first stars and galaxies burst into existence, lighting up the cosmos. The universe, once a sea of darkness, began to shimmer with points of light, each one a new star. This is the story of those galaxies, their birth, their evolution, and the secrets they hold about the cosmos, secrets that we are only beginning to uncover. It is a journey that takes us from the dawn of time to the frontiers of modern astronomy, a journey that continues to this day as we explore the universe. In the early universe, gravity acted upon the vast clouds of hydrogen and helium. These clouds, remnants of the Big Bang, were not evenly distributed. Slight variations in density meant that some regions had stronger gravitational pull than others. These denser regions acted as seeds, drawing in more and more gas. As the gas collapsed inward, it began to spin, much like a figure skater pulling in their arms. This spinning motion further intensified the gravitational pull at the center. Over millions of years, these swirling clouds of gas and dust collapsed further. The pressure and heat at their cores became so intense that nuclear fusion ignited. Stars were born, and with them, the first galaxies began to take shape. These early galaxies were much smaller and less structured than the galaxies we observe today. They were often irregular in shape, lacking the defined spirals and elliptical forms that we now know. As the universe continued to evolve, so did its galaxies. The early irregular galaxies began to merge and interact, drawn together by their mutual gravity. These cosmic dances sculpted the galaxies into new forms. One of the most striking and familiar galaxy types is the spiral galaxy. Our own Milky Way is a prime example. These galaxies are characterized by their graceful spiral arms, where vast numbers of stars are born. The spiral arms are formed by density waves that travel through the galactic disk. These waves compress the gas and dust, triggering the formation of new stars. Imagine a wave moving through a crowd, momentarily bunching people together as it passes. Spiral galaxies are dynamic and vibrant places. They are constantly evolving, with new stars igniting within their arms, while older stars shine brightly throughout the disk. While the image of a serene spiral galaxy is captivating, the universe is far from static. Galaxies are in constant motion, orbiting within vast clusters and influenced by the gravity of their neighbors. This cosmic dance inevitably leads to collisions. When galaxies collide, it is a spectacular event that unfolds over millions of years. Stars, gas, and dust are flung out into intergalactic space, creating dazzling displays of light and energy. While it might seem chaotic, these collisions are actually a vital part of galaxy evolution. When galaxies merge, they can trigger new waves of star formation and alter each other's structures. Our own Milky Way is on a collision course with the Andromeda Galaxy. Billions of years from now, these two spiral giants will merge, creating a new elliptical galaxy. Section 5. Hubble's View: Unlocking the Secrets of Space. For centuries, astronomers could only dream of observing distant galaxies in detail. That dream became a reality with the launch of the Hubble Space Telescope in 1990. This revolutionary instrument, orbiting above Earth's atmosphere, has provided us with breathtaking views of the cosmos. Hubble's sharp vision has allowed astronomers to study galaxies in unprecedented detail. It has revealed the intricate structure of spiral arms, the chaotic aftermath of galaxy collisions, and the supermassive black holes lurking at the hearts of many galaxies. One of Hubble's most remarkable achievements is the Hubble Deep Field image. By pointing the telescope at a seemingly empty patch of sky for an extended period, astronomers were able to capture the faint light of extremely distant galaxies. Section 6. James Webb, Seeing the Unseen. While Hubble has transformed our understanding of the universe, the James Webb Space Telescope, launched in 2021, promises to push the boundaries of astronomy even further. This new telescope is designed to complement and extend the discoveries of Hubble, offering a deeper and more detailed view of the cosmos. With its larger mirror and advanced instruments, James Webb can detect the faintest light from the most distant objects in the cosmos. Its capabilities far exceed those of its predecessors, allowing it to capture images and data that were previously beyond our reach. This allows us to peer back in time, observing the universe as it was just a few 100 million years after the Big Bang. By studying these ancient light sources, scientists can piece together the history and evolution of the cosmos. James Webb will be able to study the very first stars and galaxies as they formed, providing crucial insights into the early universe. This information is vital for understanding how the universe transitioned from a hot, dense state to the vast, complex structure we see today. Its infrared vision allows it to see through the clouds of gas and dust that obscure our view of many regions of space. This capability is essential for uncovering hidden phenomena and gaining a clearer picture of the universe's composition. This means we can study the processes of star and planet formation in unprecedented detail. By observing these processes, we can learn more about the conditions that lead to the birth of stars and the formation of planetary systems. James Webb is a testament to human ingenuity and our insatiable curiosity about the universe. The collaborative effort of scientists, engineers, and space agencies from around the world has made this groundbreaking mission possible. It is a tool that will undoubtedly lead to new discoveries and transform our understanding of our place in the cosmos. The images and data it provides will inspire future generations of scientists and explorers, continuing the legacy of exploration and discovery. Section 7. The Search for Life, Exoplanets, and the Galaxy. Our exploration of galaxies is not just about understanding the cosmos. It is also about searching for answers to one of humanity's most profound questions. Are we alone? The discovery of exoplanets, planets orbiting other stars, has fueled the search for life beyond Earth. Many of these exoplanets reside within the habitable zones of their stars, where conditions might be just right for liquid water to exist on their surfaces, a key ingredient for life as we know it. As we discover more and more exoplanets, the possibility of finding a world that harbors life becomes increasingly tantalizing. Our own galaxy, the Milky Way, is just one of billions of galaxies in the observable universe. Each of these galaxies likely contains billions of stars, and many of those stars likely have their own planetary systems. Section 8, Beyond the Milky Way, the Future of Exploration. The future of astronomy is filled with exciting possibilities. As we look to the stars, we are constantly reminded of the vastness and mystery of the universe. New telescopes, both on the ground and in space, are being designed to probe the universe in even greater detail. These advanced instruments will push the boundaries of our knowledge. These instruments will allow us to study the most distant galaxies, revealing their secrets and the history of the cosmos. Unravel the mysteries of dark matter and dark energy, which make up most of the universe's mass and energy, yet remain largely unknown to us, and search for signs of life on other planets. The discovery of even microbial life would be groundbreaking. One promising avenue of research is the study of gravitational waves. These waves offer a new way to observe the universe. These ripples in space-time, first detected in 2015, are caused by some of the most violent events in the universe, such as the collisions of black holes and neutron stars. By studying these events, we can gain insights into the fundamental nature of gravity. As we continue to explore the universe, we can be sure of one thing: the discoveries we make will challenge our current understanding and open new frontiers. We will make new discoveries that challenge our current understanding and inspire us to ask even deeper questions about the nature of reality. And inspire us to ask even deeper questions. The quest to comprehend the cosmos is a journey without end. The quest to comprehend the cosmos is a journey without end, and it is one that we are privileged to undertake. Each step forward brings us closer to understanding our place in the universe. And it is one that we are privileged to undertake. The future of exploration is bright and the possibilities are truly endless. Section 9. Conclusion: an ever-evolving universe. From the first moments after the Big Bang to the intricate galaxies we observe today, the universe is a place of constant change and evolution. Galaxies are not static islands in space. They are dynamic systems that interact, merge, and evolve over billions of years. Our exploration of galaxies has revealed the vastness and complexity of the cosmos. It has shown us that we are part of something much greater than ourselves, a universe teeming with possibilities. As we continue to explore the universe, we can be sure of one thing. We will make new discoveries that challenge our current understanding and inspire us to ask even deeper questions.